Today we're going to start talking about compound interest. So there are three formulas we're going to talk about today that are going to be dealing with compound interest. You have simple interest, you have interest compounded yearly, and you have interest compounded in times per year. This one right here is going to be the one that we deal with pretty much the whole time today. Simple interest basically means there's no compounding periods. A compounding period is whenever you calculate interest. Compounded yearly means you only calculate interest one time a year. Compounded in times per year means you're going to calculate it in times per year, which means you could calculate interest once a month. You could calculate it daily. You could calculate it semi-annually. There's lots of different ways you can calculate interest, but we're going to talk about compounding it so a certain amount of times per year. So we're going to talk about the compound in times per year formula the most today. Effective annual yield, basically it's figuring out how much money you would make for the year on top of what your original investment was. So if you invested $1, at the end of the year, how much money would you have? Would you have $1.10? Would you have $2? Would you have $3? So the effective annual yield will be the additional amount over what you put into the investment. And so that's what this definition is saying. So let's look at a couple of examples. So this first one, it says Norio had invested $800 in a savings account that paid 4.2% interest compounded monthly. How much money was in the account after 4 years if he left the money untouched? So this right here, compounded monthly, will tell you exactly what formula that you're going to use. Okay? So since it's compounded monthly, that means it's compounded a certain amount of times per year, which means you're going to use that formula. A equals P parentheses 1 plus R over N raised to the N T. Now you need to know what all of these values mean. A. What does A mean? A is the end amount. Okay? P is the principal, and that is how much money you start with. R is the interest rate. Okay? The interest rate as a decimal. Okay? N is compounding periods. And T is time. So those are the variables that we're going to talk about. Ending amount, principal, interest rate, compounding periods, and time. Those are going to be the ones that you need to be able to identify. On the assessment, you'll be given the formulas. You need to know what the variables mean. We're not going to tell you what each variable means. You need to know what that is so that you can input it into the formula. Okay, so there they all are. A is ending amount, P is the principal, R is the interest rate, N is compounding periods, and T is time. And time is usually in years, okay, for these type of problems. Okay, so that's what all those mean. So basically what you're going to do is you're going to go through here and just start by saying, okay, Nora has invested $800 in their savings account. 800 is the initial investment. That's the P value, so that becomes 800. Parentheses, 1 plus. It says in the savings account that paid 4.2% interest. So you need to take the R and you need to write it as a decimal, which means you have to move the decimal place 2 places to the left. So it's going to be 0.04 divided by N. N is how many times you compound it per year. Well, if we compound it monthly, there's 12 months in a year, so it's going to be 12. And then the exponent is 12 times time, which in this case is 4 years. So now what you do is you use your calculator. Well, in order to use your calculator, you're going to need one. So plug it into the calculator and see what happens. So when you type it into the calculator, you're going to get your value. So A equals $946.07. Now, how did I type that into the calculator? Don't try to type this all in at once. Do the parentheses, order of operations. So to start in here, do 1 plus 0.042 divided by 12. Hit enter. Then you're going to raise it to 12 times 4. But if you're going to do 12 times 4 in the calculator, put parentheses around it. Or you can just do 12 times 4, which is 48, and put that in. Figure out what that is, then multiply that by 800. and you get $946.07. Now, that's how much money you would have after 4 years. How do we calculate the effective annual yield? Well, that is based on 1 year, and if you look at the definition, it's based on $1. So what you would do is you'd take your principal of $1, you'd do 1 plus 0.042 divided by 12 raised to the 12 times 1 equals A. And again, type that into the calculator and see what you get. So after typing it in, I would get A equals 1.0428. Now, what that means is that's how much money you would have, which means that you've earned 4 pennies and then a fraction of pennies. Well, the effective annual yield is going to be this number minus 1. So it's going to be the effective annual yield, okay, would be 0.042. The effective annual yield is essentially what is the interest rate you're earning. So you're really earning 4.28% instead of 0.42%. And the reason why is because when you compound it, compounding is increasing the amount of money that you're actually making. Okay? So let's look at the next problem. It says Ms. Rubino has put $2,500 in a 5-year CD, certificate of deposit, that pays 7.4% compounded quarterly. How much will the CD be worth when it matures? Would it be better if the interest was compounded daily? So again, it says compound quarterly. So we're going to use the compound interest formula, which is A equals P parentheses 1 plus R over N raised to the NT. So we just go in and plug our money in. We don't know how much money we're going to have at the end. We know we put $2,500 in. 1 plus the interest rate as a decimal is 0.074 divided by quarterly, 4 times per year, raised to the 4 times 5. Now we have that in. After plugging it into the calculator, you get a value for A to be $3,607.12. Now, what would happen if I compounded this daily? So you basically get the exact same formula, 2,500 parentheses 1 plus 0.074 over, but now we're compounding it daily. There's 365 days in a year. So that becomes 365 times 5 years. Now you're going to type that into the calculator and see what happens. When you type that into the calculator, you get a value of A equals $3,619.20. So when you compound it daily, you get a little bit more money. Why? Because you compound the interest. You figure interest every day, so you get a little bit more money over those 5 years. Not a lot, but a little bit. Okay. So let's look at the next example. It says if you put $8,000 into an account, paying 7% annual interest compounded quarterly, how long until there is $12,400 in the account? So what do? Well, we plug in what we know into the formula, compound interest formula, and again, I know it's compound interest because it says compounded quarterly. So we plug in what we know. Do we know the ending amount? Yes, we do this time. We know that is $12,400. The initial investment was $8,000. Parentheses 1 plus the interest rate is 7%, written as a decimal, compounded quarterly, raised to the 4t. I don't know time. That's what I'm figuring out. Here's what we're going to use logarithms because I got to solve for an exponent. So what I'm going to do is I'm going to solve this equation for t. Using what we did before break, we're going to take this and solve for t. First thing I would do, divide everything by 8,000. So divide everything by 8,000, and you're going to get 12,400 divided by 8,000. Do that in your calculator, and you're going to get 1.55. And if you get a really long decimal there, keep that decimal stored in your calculator. Write down an estimated version, but you're going to get this. And then you have 0.07 over 4 raised to the 4t. Now, here's what the knowledge from our logarithm unit is. I need this 4t to come out of the exponent position. So what do? I put in logs or natural logs because that allows me to take this exponent and move it out front. So what you're going to do is you're going to get the natural log of 1.55 equals 4t natural log of 1 plus 0.07 divided by 4. And now we have that. Now we can solve for t. How do we do that? We divide by everything except for t. This is all multiplication, so I divide by 4 natural log of 1 plus 0.07 divided by 4 on both sides, and then we type that into the calculator. And don't try to type this all in at one time. Do it in pieces. So what would I do? Okay, so what I would do is I would actually start with the denominator. I would start with the parentheses here, and I would do 1 plus 0.07 divided by 4 and hit enter. And you get 1.0175, then you're going to do the natural log of that number, and you get 0.0173. Then you're going to multiply that by 4, and you're going to hit that number, and then you're going to do the natural log of 1.55 divided by the second answer, and you get 6.31 years. So I get time equals 6.315 years. Okay? And so then that tells you how long it would take to get to that amount. Okay? At 3% interest, compounded monthly, how long would it take to double your money? Well, what does that mean? How long does it take to double the money? Well, I know that I'm going to use this formula because it says compounded monthly. Okay? But I really don't have a lot of information other than the N and the R. I don't have P, I don't have A, I don't have T. But this doubling my money is a very key part. No matter what, if I double money, it's always going to be twice as large. So what you can do is you can pick whatever values you want. Well, if I end with $2, how much would I start with? $1. If I started with $500, I would end with $1,000. So you just kind of pick numbers that are doubled. And then this would be 1 plus 0.03 over compounded monthly, which would be 12, raised to the 12t. Now we solve just like we did on the last example. I need to solve for t. So I'm going to take the 1 divided over, which doesn't do anything. And I get this again. Okay, now how do I bring the exponent down? I put in natural logs. So I take the natural log of both sides, and then what that does is it brings the 12t out front, which is nice because now it's no longer in the exponent position. Now I can use regular algebra. Okay. And then I solve just like I did on the last problem. Divide everything by 12 natural log of 1 plus 0.03 divided by 12 to both sides. 1 plus 0.03 divided by 12. And again, don't try to type all that into the calculator at once. Start in here with your parentheses, do that, and you get 1 plus 0.03 divided by 12. Hit enter. Then do the natural log of that number and hit enter. Then multiply that by 12 and hit enter. And then do the natural log of 2 divided by the second answer, and you get 23 years. So t would equal 23.13 years. And that is how you work with compound interest formulas.